Okay, we're gonna do 2 apparent dips, and then I'm gonna take 2 strike and dip. But after I take the apparent dips, I'm not gonna tell you 2 strike and dip because we gotta work through some problems. First, you always take your GPS coordinate. I already did that. Right, you'd write it down. I'm not writing stuff down. I'm gonna verbally say it. But we got a nice planar bed here. It looks to be a cross bed. It doesn't matter. There's a lot of cross beds here. It doesn't matter if it's bed set or not. Grunt and compass right here. Set everything to 0. Make sure our thing is set to magnetic declination. In this case it is. Inclinometer set at 0. This is quadrant. It's not 360. Everything's divided in 90. Take parent dip here, parent dip here. And do true strike and dip here. I got a nice plane. So remember, you want to orient your compass when you take apparent dips. It could be either north or south, it doesn't matter, or east-west. So you look for the down dip direction, and you orient it that way, and you would write it dip or plunge first, then strike. But we're going to do it first. We have here, I have, come on, level out. Here I have about north 15, north 15 east. The dip is in that direction, because this is a lineation of 24 degrees. Now we're pretending we don't have a nice planar surface to get true strike and dip. But I want to show you how the theoretical concept works, actually works. Like works as in is successful. And this is the proper way to model it. We have our dip this way, our parent dip, and it's pointing about north 60 east. Okay? And our dip, remember, you have to measure the same bedding plane, and I am on top of the same bed, doesn't matter what it is. Our angle here is about 6 degrees. So now I will show you how to do this on a Stereonet, and we'll see what we get on true strike and dip. But I'm going to measure this one now, so we have something to check it with. We should be pretty close. If it's plus or minus 5 degrees from strike or dip, I don't care. You know, it's not that crucial. Now, before I give you the actual true strike and dip taken in the field, we're going to take those 2 lineations and plot them onto a Stereonet. Now, I'm not going to go too much into this because I've done a whole episode on the theory behind this and the actual concepts. But let's just say this circle obviously is a 2-dimensional object, but it's actually modeling a 3-dimensional ball, essentially, southern hemisphere of a globe, something like that, okay? And this right here is called your great circle around the edge here. That's your great circle. Okay, this is your northwest, east, and south. And as you can see, this is in all degrees. It goes north to here is 90, but it doesn't go 0 to 90 this way, 0 to 90, like it does in the quadrant. That's because this software is in all degrees. So we're going to have to do some converting. It's not that difficult. I'm sorry, it's just, this is free, and it's just easier to design it this way. If anyone ever wants to make it, maybe some money someday, create an app that either directly converts quadrant and azimuth, because this is what's called an azimuth plot. This would be like if you got a Brunton. You can get Bruntons like this, but I've already explained why I have the quadrant, and I'm willing to go through this headache just to not have a headache in the field, especially if it's hot or if it's raining or if you're getting eaten alive. Quadrant is better. You can always sit in your nice little air-conditioned room and deal with the minor conversions here. So this are our 2 lineations. 24 degrees, north 15 east is our first, and our second is 6 degrees, north 60 east. Now, these are dips or plunges. It doesn't matter. You can call them either or, but when we're talking lineations, we refer to them as plunge. And the reason why we do that, well, you'll see in the Stereonet, it makes it easier to plot things. You know what you're plotting and not guessing. So this here is either your trend or your strike, but we're going to say trend with delineations. So plunge and lineation. Now we have to turn these into azimuths. Now we have north 15 east and north 60 east. Now you look at this, north, and just like you go 15 east and north 60 east. So we really don't have to change anything here. We got lucky. Both are in the northeast quadrant. Now, if you had something going south and west, you'd have to convert it to these. Something in this quadrant, okay? But we don't have that. So what we're going to do is we are going to plot both our lineations. Our dips don't matter. Our plunges, they don't matter. You don't have to do anything with those other than round them when you're figuring this out. So we convert them. Our trend ends up here for our first one being 15. The plunge ends up being 24. And then our second one, trend ends up being 60. Our plunge ends up being 6. So this is how we get those into the here. You know, first what we want to do is we're going to go to calculations, go to apparent dips, because that's what we're trying to turn into true striking dip. Now we have our trends and our plunges. See, that's just the terms they use. So we have our first one is 15 and 24. So here we have 15 and 24. And our second one is 60 and 6. So we just do 60 and it's 6, and it's going to give us a result in azimuth. This 251. Now I'm going to add it to this plot. You're going to see what it looks like. We're going to actually have to convert this back to quadrant. New data set, that's all you can select. You add the data set and record, and it plots it here. And you see this curve. It's the yellow's just highlighting it. Now I want you to see the two dots, because remember, this curve is actually a plane. If you think about a plane intersecting a bowl on the inside, if that plane goes all the way through and you draw a line on the inside of the bowl, you're going to get a curve. So this is knocking a 3D oriented 2D plane down to strictly one dimension, which is in this case the curve. Now, if you think about it, lineations, which are lines, are one dimension. You knock those down a dimension, you get 0. So you're going to get dots. But I want you to see where these two plot. So now what I do to show you the dots, essentially you're done here. I just want to show you the two lineations are plotting. New data set, and you go to lines, because if you go to planes, it's going to start drawing random planes. And then what you do is you go to add datum. You want to stay clicked on that one. 1, your trend, 15, your plunge is 24. You're going to add another one, and now you do your 60 and your 6, your second one. And what do you see here? You see these two dots. Here's your first one, and here's your second one. See those little yellow circles around your black dots? Those are the actual points you plotted to get this arc and this curve. Okay? So what do we translate this to? Well, first of all, let's get our result here. We have a trend of 251.33 and a plunge of 28.15, which is directly taken from here. We don't really need all that stuff. We'll start rounding here, and we'll also now call our trend a strike and our plunge a dip, okay, because we're trying to find true strike and dip here. Remember, these are synonyms, these are synonyms. All right, so how do we figure this out? When we look at this, first of all, this curve here, your dip here, 28.15, that's the point here, the 28 here, is your furthest point from your great circle, this outer circle here, okay? And it's also the deepest on this arc. So if you drew a line through here, okay, which we're going to come back to, because when I do manual stereonets, I always draw the line through the center and meet the two ends of the arcs. And I'm going to show you why here in a second. It's also the deepest point perpendicular to that line that would run through here, okay? Now, if you notice, you'll notice your true dip is steeper than your apparent dips, and that's usually the way it is. Now, sometimes it's not under special cases, but just to remember, if you take two apparent strikes and dips, do a calculation, and you get a dip shallower, you probably did something wrong. Okay? I'm not going to show you manually how you plot these because I did that in a different episode. So that's what it looks like. Now remember, we have an imaginary line drawn through here. Okay? So we have this, and now we have this. Here's our imaginary line drawn through here. Now we have to change this to north orientation for true strike and dip. So this is not north. If we draw a line through here, it's over here. So it's going to be in the northeast quadrant. Now you look at this, and this is your 251. You look at this, and this is about 70-ish. 80 is right here. See, this is your 70 line right here. It's actually hair over. It ends up being 71, okay? So you know that's your orientation of your strike is somewhere in here. So in order to do that, in order to get from here, this 253.33 to here, you basically just have to subtract 180 degrees. Now, in the northeast quadrant, that's easy. Now, some of you might have to think a little more, but when you have a graphic like this, you can tell whichever one of these sides is going to be in your northern half. That's going to help you figure out what you have to do. But in this case, all we have to do from our strike here is subtract 180. We're going to round that to 28 degrees because it's good enough for just about anything you're ever going to do. I mean, your Brunton only reads to half a degree at best anyway, and that's with a perfect plane. So, you know, that's fine. And we get 71.33 or approximately 71. So our strike and dip, if we write it, our strike, north 71 east, because we're using this 71, oriented north, and our dip is 28 to the northwest. So that's your north 71 east and your 28 to the northwest. So that's how you would simply do that. Now we are going to watch the last part of that field episode where I take an actual strike and dip on that same bedding plane and see if this concept, using this Stereonet, actually is an accurate model and can be used to calculate strike and dip if you can't get it. Let's watch that and then we'll come back. North is actually almost to the camera. So my strike, you set your inclinometer back to 0. My actual strike, always done from north now, is north 70 east. North 70 east. And my dip is 29 degrees to the northwest. Okay, so you saw that I had gotten in the field north 70 east, 29 northwest. So this blue is our calculated strike and dip. This black is our measured strike and dip. They're only a degree off. The strike is a degree off, the dip is a degree off. And if you actually use these numbers, it's even less than a degree. So this concept works. I know it looks odd when you look at this round bowl looking thing, circle, and this arc or plane, and then these two dots or lineations, and I wonder just how does that model it? Now, you know, I have done this and shown the theory behind this in a totally another video, so I'm not going to do it here, but this is just to show you that this works. And this is what I do. I solve everything graphically like this. I don't fumble around on a calculator because I think spatially. So if I do this, I'm not likely to screw up. If I'm punching numbers on a calculator, I could flip a sine or cosine or whatever and be totally off. Anyway, that's it. Let's move on.